Hey gang, so I am on page 10, which still kind of goes along with the velocity from the previous lesson. The slope of a curve is the same as the instantaneous velocity. We just discovered that on the last video. So just a reminder, when you have algebra, you're just talking about the slope. You're talking about the rate of change. So something like y equals 3x minus 1, we would say the slope is 3, and we would call it the rate of change. In calculus, when we're talking about the slope of a curve at a point, we're talking about the instantaneous rate of change. Just at that instant, what happens? What's the slope of the curve at the point? And where we said that the slope equals, oh, you know what? I didn't put that on there. The slope is y2 minus y1 over x2 minus x1. In calculus, we're going to say the average rate. And we're going to do the instantaneous rate. Well, the average rate we found was f of x naught plus h minus f of x naught, all all divided by h. And what we found with the instantaneous rate, that was where we said, okay, that's a limit. That's as h approaches 0. In other words, you're getting that distance closer and closest to that exact point. We did the same thing. F of x naught plus h minus f of x naught all over h. And I think I actually used t in there when I was doing that too. Sorry, I had like a sneezing fit right before I started my video. Now I'm like, okay, that just sounds gross. Okay. Find the average and instantaneous rate of this curve. Okay, we're going to do two things. For the average rate, we're going to find it over the interval. We're going to do the interval 2 to 5. So x is 2, and then x is 5. For the interval, instantaneous, we're going to do at negative 2. Instantaneous at x equals negative 2. I think I spelled all that right. I don't even know. Okay, so we're going to start off with the average velocity because that one's the easiest. We're just going to do the first one minus the second one, all divided by h, right? Okay, so here we go. So x naught. We're starting at 2. So x naught plus h, because remember that's what we've got to do up here. So we're going a distance of 5, right? So 5 minus 2 would be 3. So that means that h must be 3. 2 plus 3 would get me to 5. Hopefully that makes sense. You follow what I do. You're really just subtracting that distance there. So you're going 3. So from 2, you're going over 3 more to 5. So here's the information I need. Now let's go up and let's do the average rate of change. Average velocity will be f of x plus, there it is, f of x plus h, which is f of 3, minus f of x naught, which is 2, f of 2, sorry, all over h, which in this case is 3. Why do I feel like that is not right? I paused my video, but I've learned that when I pause my video, it doesn't work. So x naught plus h is 5. That's what's wrong. I'm like, something's not right on that. X naught plus h, that would be, that would be 5 right there. X naught plus h is 5. And then we did 5 minus 2. You know what, let's just change that. I just feel like that's confusing. Is 5. And then h is 5 minus 2, which is 3. Let's do it like that. That looks a little better. Those of you that don't like boo-boos, we got a boo-boo. Okay, so here we go. F of 5. So I'm going to plug this in. I don't have it right on my paper because I didn't use the right numbers. So I'm going to say 3 parenthesis, where am I at? 5 squared minus 4, that's f of 5 right here, f of 3, f of 5, minus f of 2, which is going to be 3 times x squared, which will be 2 squared, minus 4. F of x naught plus h, and then the other one, all over 3. I'm going to see if I get the same answer. Like sometimes I'll work it and I'll get it wrong. All right, so since it's the same equation, I'm going to be lazy, and I'm going to do f of x squared minus 4. I'm just going to do it this way. All right, I need f of 5. I got, oh, I took my contacts out. I can't see it. Negative 3.4. Why am I getting a negative? Y'all, I should just start this video over, shouldn't I? Oh, because I didn't type it in. 3x squared minus 4. Okay, here we go. That's 71. Yes, I did it right on my paper, but I did not do it right in here. 71 minus, all of this is going to come out to be 8 over 3, which is going to be 21. All right, my numbers were right on my paper, but my numbers I plugged in here were incorrect. Okay, let's hopefully I get better at this. Okay, now let's do instantaneous. So we need to do a limit. So for instantaneous, I'll put instantaneous rate. I'm going to say the limit as h approaches 0 of, okay. Oh, I don't have much room on here, so I'm going to try and do this here. I know I need to do f of x naught plus h, right? So we're going to plug in x plus h everywhere we see an x. So we're going to do 3 times x plus h. I'm going to drop the naught just while I'm writing this out here, and then I'll go back to it. Minus 4. That's f of x plus h, right? F of x, I already know is 3x squared. But let me simplify this. That will be 3 times x plus h times x plus h. Remember, this is the algebra part. Minus 4. 3. Now, I'm going to multiply this out, and I'm going to do it in my head kind of quick. That'll be x squared plus xh plus xh plus h squared minus 4. I'm going to combine these terms and multiply by 3 all at once. 3x squared, that'll be 2. 2 times 3 is 6xh plus 3h squared minus 4. Okay, that is f of x plus h. So this right here, I'm going to write up here all of this. So the limit, and we'll put f of x plus h minus f of x all over h. So I'm going to use these values. I'm going to use this one right here, and I'm going to use this one right here. All right, so remember we got to write our limit again as h approaches 0. The first one is this, so write kind of small so you can get it all in. 3x squared plus 6xh plus 3h squared minus 4 minus all of this. Now, I'm going to go ahead and write it this way because I feel like I'll mess it up if I do it the other way. Minus 4. All over h. Okay. We're going to see what can we cancel out. I know I can change. Oh, y'all, I just threw the lid to my pen somewhere. Oh, dear. Oh, there it is. Sorry. It fell in my trash can over here. Y'all can't see it. Oh, the joys of making videos late at night when you're tired. Okay. Let's try it one more time. What can I cancel out? So this negative right here is going to make, I'm going to change this to plus, and I'm going to make this a negative, and negative times a negative, that'd be a positive. 3x squared and negative 3x squared. Bam, gone. Negative 4, positive 4. Bam, gone. I am left with the limit as h approaches 0 of 6xh plus 3h squared all over h. I need to simplify that, so I'm going to take the limit as h approaches 0. I'm going to factor out an h and be left with 6x plus 3h all over h. My h's will cancel. Bam. I can plug in the 0. So I can now say it equals 6x plus 3, replace the h with 0, which means this is simply 6x. So the instantaneous velocity rate is 6 times x. Let's see if that works. What is 6 times, where am I at? Where am I going? Where am I going? Well, you got the instantaneous rate. So we have to do of -2. Why did I? Oh, that's what I was doing. At -2, instantaneous rate at x equals -2. I knew there was something. So, you know what? I'm just going to put it right here. I'm going to say the instantaneous rate equals 6 times -2, which would be -12 at that moment of -2. So we found that one. I'm going to go ahead and highlight it just so we know which one we're finding. We found that one. And then, do I have another highlighter? And the average velocity between 2 and 5 was 21. All right, there we go. Okay, so that concludes this. I'm going to actually stop this video here because the next one picks up on derivatives, and that's a whole other topic.